Hey, welcome back to Bed Squid. In this video, we're going to be doing coordinate geometry review part 2. Okay, so question 1, let's just jump straight into this. Plot the points P, Q, R, S on the same set of axes. Remember, X is first and then Y. X is always left and right, and Y is up and down. So we're going to plot these points. We're going to have 2, 5, so 2 and up 5. That's the point P. We can write down here 2, 5. Point Q is 3, -3, so 3, -3. That's there. That's Q. We can call it 3, -3. Right, R is -4, 0, so -4, 0, that point there. And then S is -2, -4, so -2, and then down to -4. That's S. Going on to question 2 then, it says find by inspection the equation of the straight line passing through these points. So you're not supposed to do any calculations here. You don't need to substitute into the equation y equals mx plus c to find out the equation. You don't even need to use the gradient formula here to see what's going on, okay, which is y2 minus y1 over x2 minus x1. So pause the video, see if you can do it for yourself, and then I'll show you my solution. So just by inspection, for all the points on the line, we can see that x plus y is equal to 3, x plus y is equal to 3, x plus y is equal to 3. They're always equal to 3. So we can write this down then. For all the points on the line, the x plus y coordinate equals 3. So we can write that as an equation. X plus y is equal to 3, or we can write in the same format as y equals mx plus c. We can say y is equal to minus x plus 3, and that's just by inspection. We haven't used any formula, we haven't used the gradient, or we haven't substituted any values in. Okay. Question 3, a tank contains 400 liters of water. The tap is left on and 20 liters of water escape per minute. Suppose V is the volume of the water remaining in the tank t minutes after the tap is turned on. Part A, what are the independent and dependent variables of this question? So there are two variables that are given to us, V, which is the volume of the water tank, and T, which is the time in minutes. Now remember, time is usually on the x-axis, which is our independent variable, which leaves us with the volume as the dependent variable. So the volume of the remaining water in the tank depends on the time t minutes after the tap is turned on. Part B and Part C, make a table of values for V and T for T is equal to 0, 2, 4, 6, 8 and 10 minutes. So for the table of values, we're going to do V against T. V is the volume, and then T is 0, 2, 4, 6, 8 and 10. So remember, the container contains 400 liters of water to begin with. At T is equal to 0, we have 400 liters of water. And then as the tap is left on, we have 20 liters of water escaping per minute. So after 2 minutes, we will minus 40 liters, which will give us 360. And then another 2 minutes, we will minus 40 liters, which will give us 320, and so on and so on and so on. So 320, 280. And then 240, and then finally at 10 minutes we will have 200 liters of water. Okay, so we can have the following graph with t at the x-axis going up in 2s, and we should put the units there, which is minutes, and then the volume, which is in liters, going along the y-axis. Now bear in mind that we have a broken axis here because it starts at 200, so it's better to do a broken axis. And now we're going to plot the information that we have. At 0 we have 400, and then at 2 minutes we have 360, 4 minutes 320, at 6 minutes 280, at 8 minutes 240, and then at 10 minutes 200. So part D, is the relationship between V and T linear? Well, going back to our graph, what do you think? Okay, because all the points lie on a straight line, the relationship is linear, and we can confirm that as well by looking at the table of values, because on the table of values we have a constant change of minus 40 liters every 2 minutes. Parts E and F then for question 3, is it sensible to join the points graphed with a straight line? Explain your answer. And also, for every increase of 1 minute for T, what is the change in V? Let me go back to the graph and you can answer this question. So the answer to part E, is it sensible to join the points with a line? Yes, it is, because as the water is dripping out of the tap, it doesn't matter how many minutes have passed by, the water is going to continue to drop until the tank is fully empty. For part F, for every increase of 1 minute for T, what is a change in V? The answer to this is in the text anyway. It says the tap is left on and 20 litres of water escape per minute. So the change in volume for every minute the tap is left on is minus 20 or minus 20 litres. Parts G and H, how much water is left in the tank after 2.5 minutes? And how long will it take for the volume of water in the tank to fall to 310 litres? Make a note of the questions because I'm going to go back to the graph for you to answer them. So let's zoom in and have a look at 2.5 minutes. So that's 3, so be careful. We don't want 3 minutes, we want 2.5. So let's go up. We draw a line to 2.5 until we hit the line, and then we can go across and see what we have. So from 320 to 360, we've gone up in an increment of 40. That means that this point here would be 20. So that'd be 320 plus 20, which is 340. And then that part there would probably be about 350 litres. So after 2.5 minutes, there will be 350 litres remaining in the tank. So the answer to the next part is how long will it take for the water to be at a level of 310 litres? So this mark here would be 300 exactly. 310 would be this part here. So let's go across to the graph and then down. And it would be, remember that's 5 minutes, so it would be 4.5 minutes. So it would take 4.5 minutes for the water to be at a level of 310 litres. Okay, so moving on to question 4, it says on grid paper or any squared paper, draw a line with a gradient of part A 2/5, B -4/3, and C 0. So do this on a piece of paper and then you can comment in the section below. Okay, so that could represent our grid paper. What we're really looking for is the top part is the rise and the bottom part is the run. Okay, so we have a rise of 2 units and a run of 5 units. So if we start at any point, let's say we started at this point here, we want a rise of 2 units, so 2 up and then 5 across. So 1, 2, 3, 4, 5. So we will end up at that point. So the line that I'm looking for then is from this point going up to here. That would have a gradient of 2/5. Part B, let's see if we can do this. So we have a rise of -4 units. That's our rise. And our run's going to be 3. So we're going to go down 4 units. So 1, 2, 3, 4. That up to here. And then 3 units to the right. 1, 2, 3 over here. So we're going to have then a straight line from this point going down. Remember, this is negative. Unlike the first one, which was positive, it was going up. So a 0 gradient is a flat line. So any flat line here like this, rise over run. It doesn't matter what the run is. Run could be 4 as long as the rise is 0. So this is our flat line. It has a gradient of 0. We have our lovely gradient of 0 here, and we have a gradient of -4/3 here. Okay, question 5 says find the gradient of the straight line through the points. These are the points. Make sure you pause the video here and you try to answer these questions in the comment section. So for all these questions, we're going to be using the formula y2 minus y1 over x2 minus x1. That's going to give us the gradient. Okay, so let's do this. For part A, we're going to have the points 2, 1 and 8, 13. I'm going to label my points as x1, y1, x2, y2, and then I'm going to substitute those into the formula. So I've got 13 minus 1 divided by 8 minus 2. So that gives me 12/6, which is a gradient of 2 then. Part B, we have -2 and 3. And we also have 1 and -4. So label your points, x1, y1, x2, y2, and then substitute them in. So we have minus 4 minus 3 minus 7, and then 1 plus 2 is 3. That's our gradient. We have a gradient of minus 7 over 3. For C, we have the coordinates -1 and -5, and also 9 and 3. So part D, 5 over minus 3. Okay, or it could be minus 5 over 3. Doesn't really make a difference. Question 6, draw a line through the points. In fact, what I would like you to do is write the equation for parts A and B. Okay, so remember, every straight line has the equation y equals mx plus c. So we have the following coordinates. We have an x and a y, and we have the gradient, which is our m. So let's substitute that information into our equation. We have 5 is equal to a quarter times 3 plus c. So that's 3 over 4 is equal to 5 plus c. Now, if I rearrange this, I can say 5 minus 3 over 4 is equal to c. So therefore, c is equal to 4 and 1/4. So the equation for the line would be y is equal to a quarter x plus 4 1/4. For part B, that's my x and my y, and I have my m. So let's substitute this information in. We have 3 is equal to -2 bracket -2 plus c. So we have 3 is equal to 4 plus c. If I minus the 4 on both sides, I end up getting -1 is equal to c. Therefore, c is equal to -1, and my equation is y is equal to -2x minus 1. Question 7, determine whether the points -2, 5 lie on the line with equation y is equal to -2x plus 1. Okay, so we have the equation y is equal to -2x plus 1, and we have the following points of x and y. We're going to substitute them into the equation to see what we get. So we've got 5 is equal to -2 bracket -2 plus 1. This is 5 is equal to 4 plus 1. 5 is equal to 5. So therefore, the points do lie on the line. Question 8. For each of the following lines, state the gradient and the y-intercept. Draw the graph of the line. Now you can do that on a separate piece of paper. However, I would like you to comment on this part in the section below. Okay, so remember, y is equal to mx plus c. C is my y-intercept, and m is the gradient. So in the equation, y is equal to -1/3 x plus 2. We have a gradient of -1/3, and we have a y-intercept of 2. For part B, y is equal to 3/4 x minus 3. We have a gradient of 3/4 and a y-intercept of -3. Question 9. Find the equation of each line. Okay, so we have the x and the y-intercept. For line A, we know that the x-intercept is at 4, 0, and that the y-intercept is at 0, 3. We can use this information to find the equation. So I would substitute 3 minus 0 divided by 0 minus 4, which will give me a gradient of 3 over -4. That's the gradient. And now for the y-intercept, I need to choose one of these values to substitute into the equation y is equal to mx plus c. So I'm going to go ahead and use the y-intercept, and you'll see why in a bit. I've got 3 is equal to -3 over 4 times 0 plus c. Anything times 0 is 0, that cancels out. Therefore, c is equal to 3. So my equation for the line is going to be y is equal to -3/4 x plus 3. For part B, we have the y-intercept. So we can write down the y-intercept, which is 0, 4, and then we have a second point, which is -2, 2. So we'll use these points to find the gradient. So that will give us -2 over -2, which gives us a gradient of 1. And now we can use one of these points to substitute into the equation. And I'm going to go ahead and use the y-intercept. So I've got 4 is equal to 1 times 0 plus c. Anything times 0 is 0. Therefore, c is equal to 4. And my equation is going to be y is equal to 1x plus 4. Now I don't need to write the 1. I can just write x plus 4. Y is equal to x plus 4. Okay, the final question. For the line given, find the x-intercept, the y-intercept, and then the equation of the line. So the x-intercept is where the line cuts through the x-axis, and at this point we have 2, 0. So that's the coordinate for the x-intercept. The y-intercept happens when the line cuts through the y-axis, and that's at -3. So we have 0, -3. For the equation of the line, here's a trick. Now I'm going to zoom into the graph and you can see what I'm doing here. This is 3 units up and 2 to the right. So 3 up and 2 to the right to get to the line. That's 3 up and 2 to the right, which is the same as my rise over my run, which is the gradient. Okay, so my gradient here, just by using the graph, I'm going 3 up and 2 across. That's 3/2. So my gradient is 3/2. I already know what the y-intercept is. It's -3. So I'm going to have 3/2x minus 3 is equal to y. My equation is y is equal to 3/2x minus 3. Now, if you really want to confirm this, substitute the points into the gradient formula. So you have -3 over -2, which is the same as 3/2. And that's what we got over here, 3/2. And then the y-intercept obviously is the y-intercept. So we end up getting y is equal to 3/2x minus 3. Okay, so thanks for sticking along. I hope you've done really well. And if you haven't, you can always go back and watch the video again until you fully master the concept.